Hey everyone, in this video we're exploring the Java 2025 roadmap. Whether you're a beginner or an experienced developer, this guide will help you master Java and build scalable systems. Let's dive in. First up, let's talk about Java Core. This is the foundation of the Java programming language. It's what enables you to develop cross-purpose applications that are secure, scalable, and high performance. Now, let's break down the Java fundamentals. You'll start with the basics: variables, data types, operators, and keywords. Then you'll move on to control flow statements like if-else, switch, and loops. Don't forget about methods and encapsulation. These are crucial for writing clean, maintainable code. And of course, you can't skip object-oriented programming, OOP. This is where you'll learn about classes, objects, inheritance, and polymorphism. Wait, there's more! You'll also dive into exception handling, arrays, collections, and the basics of Java API like working with strings, string builder, and date and time classes. These are the building blocks of any Java application. Once you've got the basics down, it's time to level up with advanced Java. We begin with advanced OOP concepts, which focus on enhancing object-oriented design using principles like solid and design patterns. To complement this, generics and collections ensure type safety and efficient data handling, making Java applications more robust. As applications grow in complexity, concurrency becomes essential for managing multi-threading and parallel execution. Alongside this, functional programming introduces powerful features like lambdas, streams, and functional interfaces, enabling cleaner and more efficient code. Handling data is another crucial aspect, and Java I/O provides the necessary tools for file operations and data streams. For applications targeting a global audience, localization helps adapt them to different languages and regions. Finally, modules, introduced in Java 9, allow for better organization of large applications by enabling modular programming, improving maintainability and scalability. Now let's talk about frameworks and tools. These are what make Java development faster and more efficient. The Spring Framework is a widely used framework that provides comprehensive support for building enterprise applications, offering features like dependency injection, MVC architecture, and robust security. Next, we have Quarkus, a framework optimized for cloud-native and microservices applications. It is designed for fast startup times and low memory usage, making it ideal for containerized environments. Finally, Micronaut is another modern framework built for microservices and serverless applications. It emphasizes minimal memory footprint, compile-time dependency injection, and seamless integration with cloud services. Each of these frameworks serves different needs but shares the goal of making Java development more efficient and scalable. For building your projects, you've got options like Maven and Gradle. These tools help you manage dependencies and streamline your build process. And if you're working with messaging systems, you'll likely encounter Apache Kafka, RabbitMQ, or Apache ActiveMQ. Of course, you'll need a good IDE to write your code. Popular choices include Eclipse, IntelliJ IDE, and Visual Studio Code. And when it comes to databases, Java has you covered. This slide presents key aspects of database interaction in Java application. We begin with SQL and NoSQL databases, where SQL databases like MySQL and PostgreSQL provide structured data storage with relational integrity, while NoSQL databases like MongoDB and Cassandra offer flexibility for handling unstructured and scalable data. To manage database versioning and changes efficiently, database migrations tools like Flyway and Liquibase help automate schema updates, ensuring consistency across different environments. Finally, object relational mapping, or MRM frameworks, like Hibernate and JPA, simplify database interactions by allowing developers to work with Java objects instead of writing raw SQL queries, improving maintainability and reducing boilerplate code. Together, these components form the foundation of effective database management in modern Java applications. Security and authentication in Java applications protect data and ensure only authorized access. Let's say you want to protect your app from vulnerabilities like SQL injection, SSS, and CSRF. Tools like OWSP Dependency Check can help you stay on top of security risks. And for authentication and authorization, you'll likely use OpenID Connect, JWT, Auth2, or Spring Security. Now let's talk about software architecture and best practices. You'll want to familiarize yourself with design patterns like singleton, observer, factory, adapter, decorator, iterator. These patterns help you solve common problems in a clean and maintainable way. And don't forget about the solid principles. These are key to writing good, scalable code. Single responsibility ensures each class has one purpose, while open-close allows code to be extended without modification. Liskov substitution ensures subclasses can replace their parent classes without issues. Interface segregation promotes small, specific interfaces over large general ones, and dependency inversion encourages relying on abstractions rather than concrete implementations. Together, these principles improve code flexibility, readability, and maintainability. When it comes to API design, you'll want to follow RESTful best practices. Tools like OpenAPI or Swagger can help you design and document your APIs effectively, and many others. Testing is another critical part of the development process. You'll start with unit testing using tools like JUnit and Mockito. Then, you'll move on to integration testing with tools like test containers and Spring Boot Test. And finally, you'll want to do functional testing to make sure your business logic meets the requirements. Last but not least, let's talk about CI/CD. Continuous integration and continuous delivery are essential for modern software development. Tools like Docker, Jenkins, GitHub Actions, and Kubernetes can help you automate your workflow and ensure a smooth deployment process. And there you have it, the Java 2025 roadmap. From Java core to advanced concepts, frameworks, tools, and best practices, this roadmap covers everything you need to master Java and build scalable backend systems. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more content like this. And if you have any questions or want to share your Java journey, drop a comment below. Thanks for watching, and I'll see you in the next video.